Em abril de 2025, o Fundcast foi à Europa para participar da Bauma, maior feira do mundo para equipamentos e ferramentas de construção civil. No caminho fizemos algumas visitas especiais, e nesse episódio, gravado em Roma, conversamos com Diego Marchetti, que nos recebeu no Studio Marchetti para uma verdadeira aula sobre investigação geotécnica e a obra de seu pai, professor Silvano Marchetti, uma lenda para a geotecnia. Seja bem-vindo a mais um episódio do Fundcast.
So, we are on Studio Marchetti, and Diego, thank you very much for welcoming us here. For me, it's a really pleasure to be here and to see all the history that you have, you and your father, everything that you built along all these years. And for you to know that studying geotechnics in Brazil, the name Marchetti is like a legend in geotechnical engineering. So being here where everything just started, it's an immense pleasure. Thank you very much for welcoming us here.
Thank you for coming. It's a pleasure also for us.
So Diego, I think we have some things that we can talk and share the information with who is watching us. I would like to first try to understand the origins of the DMT, the motivation of its creation and how it evolved.
Yes, the DMT was developed by my father, Professor Marchetti, in the late 70s. He was a consultant working with Mike Yamalkowski in his office. He graduated with Professor Yamalkowski and then worked in his studio for a lot of projects in those years. And what he told me is that when he designed, he could not have reliable parameters with the current available tests, meaning laboratory that were commonly with very low values because they were disturbed samples that gave always values that were too low, or devices like SPT or the beginning of the CPTs that were still not so reliable and also were mainly measurements of strength. And so he really was trying to, I saw the old geometries of the DMT with two membranes on both sides and rods that were not circular but rectangular sections. So he did a lot of refining to arrive to the solution of the DMT, but the main reason was to obtain parameters that were useful for him as a designer to obtain parameters, and in particular horizontal stress and the modulus, which are the strong and the most important parameters that the DMT is able to provide even today.
Mm-hmm. It's very nice to hear that, and I think DMT, it was and it is a kind of a revolution in the geotechnical industry, and I think that he must have faced some resistance in the beginning of this, and how it became accepted by the geotechnical community.
Nice question, because basically I lived all my life in this period, because approximately when I started to be a 10-year-old, he was living this moment of first introducing the DMT equipment in the world, and so we used to go. I went with him many times, even when I was very young, to conferences where he used to explain exactly from zero how the equipment worked, and there was a lot of interest from all the scientists. And we went also to live in America, where he was invited by Professor Schmertman in Florida, and then they organized a conference in Canada. So a lot started in North America in the 80s and mid-80s, and he spent a lot of time trying to introducing this equipment. And at the beginning there was a lot of interest, and then there was it started a little bit to be a competition to the CPT. So that's where the phase was a little bit more delicate in terms of what you were asking. There was a time in which at conferences a lot of questions were, shall I use the CPT or the DMT? And so also other interests came in account, and so that was the hard time to convince the world, because he was the only developer of the system, and there were a lot of CPT companies manufacturing. But then, especially in the successive decades, I started to work with him in the early 2000s, and we came to understand that comparing the results, we could find how to increase the knowledge on the soil characterization, using both the equipments and parameters that are given by the ratio of the two, of the results of the two equipments. And so this is a benefit in terms of knowledge on the soil. And so, yeah, that's...
Well, it's very good to hear that. And you were showing me down in your laboratory, but over the years, the DMT has also evolved significantly. And what were the main advancements from the original version developed by Professor Silvano?
Yes, well, to make it short, because if not, it would become too long. Professor Marchetti, he invented the traditional DMT, which is the blade, you know well, with a membrane. And the main difference with what is now is that before you had a control unit, a pneumatic control unit, and you would provide the gas from the surface, the pressure from the surface. And so you would generate and measure the pressure at surface, and it was purely mechanical. So you had to read the pressure on the pressure gauges. When I started to work with him, I'm a computer science engineer, so that's my background, but I attended several geotechnical exams in the university. I first developed the automatic acquisition of the data. So to have more accurate data, getting from a digital acquisition of the data instead of reading from analog mechanical pressure gauges. And the second development we worked at was the seismic. So really, I spent 12 years. My father made me go with the truck around to do the tests, and using the seismic system we had developed, I developed the electronics. I wrote myself the software of the chips, and then the acquisition and the processing of the results. And so I saw the whole process of the seismic, from data in the field to data processing and the results of VS. And that's why I think it is now very successful. And you may not be aware that there are two companies who manufacture CPT and make seismic CPT who use our seismic in their CPT, which are GeoMill and Gouda Geo. And we did it also with Pagani, but now they make their own seismic. And we're in contact with Vertec in US, who is now our representative in the United States, and Geotech Sweden, and Vandenberg also. So many clients of ours of the DMT and seismic DMT want to do the seismic CPT, and they ask for our seismic with the CPT. We don't make CPT, we don't want to. There are many companies who do it, but we think our seismic is good, so we are happy to offer it for combination with the CPT of any constructor who wants to do this combination. The last development I had conceived before my father in 2007, 2008. I was conceiving the Medusa, and I told my father, why don't we make an automated Medusa DMT so that we don't need a control unit, a gas tank. And at the beginning, he was not very in agreement with me. I even brought some pieces that I kept for a museum in the future to remember to have this memory. And then after 5 years, he came up to me and he said, I think it's a good idea, because this way we can eliminate some operator inflation, deflation, and also the pressure, instead of generating and measure it at surface and going through a cable down, you can have a difference of pressure. Now it's with oil in the device at the depth. So we increase the accuracy in an impressive manner. And there is a conference where a professor from Brazil, Professor Danziger, I'm sure you know him.
Yes.
He wrote a paper of the difference between doing it in a very soft soil research test site in Rio de Janeiro, Sarapui is the name, with the mechanical DMT and with the Medusa. And with the mechanical, there was scatter, but we're talking about 10 kPa of difference between the pressure readings. And with the Medusa, it was perfectly consistent. And so this final creature of Medusa is really, I think, now the latest evolution of the DMT. I hope there will be some more, but I can't imagine it now for the moment. And it is being used a lot also offshore. If you have to do deep tests, having a long cable makes it impossible to have accurate measurements. So that's one of the points. And also offshore for deep water depth, the same thing. If you have a cable coming up and you pressurize from the surface, it's not the same if you have an engine who is able to very accurately pressurize and measure with extreme accuracy and repeatability. And of course, we then, the last stage was to add the seismic sensors in the Medusa, which may appear simple because we did the SDMT, but it was not, because inside that tube there is really a lot of components. We drew the design, we draw that ourselves. Every component in there except the pressure transducer and the engine was designed by us. It's a tailored design to make it fit in a tube, and so that's why we took a lot of years, and now we are very happy to have it ready for it's widespread in all the continents, maybe not in Asia, but Australia, Africa, Europe, North America, and South America. So it's growing well and fast.
It's impressive. It was a pleasure to go to your studio and see the Medusa and the details inside things. And previously you mentioned about Professor Jamilkowski, which was a legend in geotechnical engineering, as your father was too. And I was curious just to know more about how they work together in important projects, and could you tell more about their collaborations and what kind of contributions came from it?
Yes, I can tell you, and I refreshed it very very recently, because in November there was in Turin a memorial day for Professor Mike Jamalkowski, where he was at the University of Politecnico di Torino in Turin, and they called me to do a presentation on your question. So I showed many pictures. Just to give you an idea, Professor Jamalkowski was the witness of the marriage of my parents. So they were very good friends. Mike was a bit older than my father, and my father graduated with him and was the first student of Mike Jamalkowski, and graduated. He was 1 year ahead. He was, I think, the first professor in Italy for age. And as soon as he graduated with Mike, he was sent by Mike to Imperial College in London, and then he returned and started working at consultancy with Mike. And there he always told me that he learned so much from Mike, because Mike was an impressively knowledgeable person, very hard worker, and he was accepted in the whole world in the most important project of the world. You are aware of, not only in Italy with the Pisa Tower or the Venezia Mose project, but also in Poland for the tailing dams, and many other projects worldwide. So they were friends. They would play basketball together, and they went to conferences together. I met him at a very late stage, of course, but I did some tests for him with the truck during the early 2000 years. And so to answer your question, he played an important role, especially with my father, especially for promoting the equipment and believing in it and helping us in the development. He was a strong sustainer of developing the seismic that we did. So his contribution is important for the DMT, definitely.
It's very nice to see the details of their relationship. I didn't know that they studied together. They were that close, and it's very nice. Professor Jamilkowski, he received the International Society Award, a Lifetime Award. Unfortunately, he passed away a bit before when it was conceived, but it's very important that he got that award.
He was also president of the International Society of Soil Mechanics. I can't remember when, I think, and around 2000, early 2000 probably.
It's legend.
A legend. Right.
I would suggest us to discuss a bit about the soil characterization and parameterization using the DMT. And I would say that my experience with DMT it's pretty limited. Probably I have like 10 cases which I've worked with DMT. And I think the implementation of DMT in Brazil, it's evolving, progressing at a really slow pace. From your perspective, what are the applications where the DMT truly stands out?
Well, first of all, the scope. I mean, the DMT, as I said, can be done in any type of clay, silt, or sand, where you can penetrate the DMT, and very similar to the scope of application of the CPT. I think the DMT stands out for, especially when it is necessary to evaluate, as I said, horizontal stress and modulus, but it works very, very well for profiling the soil, like the CPT. So if it's clay, silt, or sand, it provides also strength parameters through the stress history parameters that it measures with stemming out from the horizontal stress measurement. You can do dissipation tests to evaluate the permeability. And now with the Medusa, we are doing measurements that could not be possible before. Basically, we are able to push the Medusa, and while we advance it at a fixed speed like the CPT, we measure the horizontal stress in a fully undrained matter. And a paper from Danziger was present in the conference in Barcelona showing a repeatability that was almost unbelievable. For the results were right on top of each other. So I think that even in the next future, the device will be will play a key role for getting even closer to K0. Also in tailings dams, we're working a lot on that. And in terms of partial drainage, there are many materials that are not fully drained, like sand, or not fully undrained, and clays, they're partially drained, like silt. And so that's where both CPT and DMT suffer a bit in interpretation, because according to the speed with which you penetrate or expand the membrane, your results change. And so now that we can do measurements even while penetrating, we are comparing different speeds of penetration, different speeds of membrane expansion. And when we will have organized this work, I think it could happen that we have a strong step forward for K0 and for the determining parameters of partial drainage. We're working on it, of course.
We were talking before in the backstage about like SPT, CPT, DMT, and it was very interesting to hear from you that we don't need to make like a competition, or you should use one or the other. I think it's important. I would like to say it again, that we can add. We have SPT, then we have CPT, then we have DMT. Every test can add something different, and we can work all together, which brings more information, different information. And please repeat that for us.
Yes, I definitely confirm that there is not one test that has to survive and the rest have to be eliminated. It's a cooperation between all the tools. Every tool, I think, has specific optimal application where it is the most appropriate compared to others, including DMT, CPT, and pressure meter. We can make examples. When the soil is not penetrable, you cannot deal with the DMT and the CPT. And in my opinion, the SPT and the pressure meter are excellent solutions, especially if you are in like a dense gravel or in rock, you use pressure meter or rock dilatometer. But if the soil is very soft or is penetrable, I think it's a pity not to do DMT and with or without a CPT, because together these tools can give you a so complete picture of the test, of the results. You can compare the stratigraphy from CPT and DMT, compare the strength. The modulus normally is used, the DMT, to calibrate the CPT, and the horizontal stress K0 and OCR, which is really important because it's a stress history. you want to know if your soil is normally consolidated or it was pre-compressed by a glacier, well, maybe not in your country, but by past loads that are not there anymore. And so really stress history is a key factor, and so is horizontal stress, which I believe is something that is a little bit missing in soil characterization today, especially with primitive tests like the SPT or laboratory, where when you take the sample, you're not always sure of the quality and the representativeness of that sample of the layer that you want to characterize.
One thing that I'm working, I have a big interest is with the result of seismic wave velocity readings. I think it will be used every time more. I think it's kind of the future of the soil investigation. And from my perspective as a foundation designer, the main interest in the seismic wave velocity is to work with the formability parameters. So let's say predict the settlement of a building. And it's a recent case. I have a tower which is already completed from some years. I have all the settlement readings which were made in a really good way. It's a 167 meter tall tower. And what we have done is working with settlement models to predict and using seismic wave velocity for all the layers, soil layers, to go with modulus. And what we have done is the seismic wave velocity gives you let's say the G naught. Then we need to interpret the modulus to be compatible with that foundation problem. So normally what we do, let's say in a simple manner, is just to use like 20% of the G naught. It would be used for a foundation problem. My question for you would be like, I have access some works, some papers that use the DMT to try to predict the soil degradation, the modulus degradation curve. And I would like to understand if there's something going on with that, if you can tell us more about it.
Yes, I am definitely familiar with these studies and papers. VS is definitely an important parameter because from G naught you get the modulus at low strain. So with very low deformability, you have the original maximum modulus, G max or G naught. Then if you knew the full curve that you can get from laboratory, it would be the best way to evaluate the settlements, because every time as you have your deformation, you get the right modulus according to the strain. Now, not many are aware, but there are several publications on this, that the modulus MDMT is at an intermediate strain level, which is the one typical of the settlements of buildings and normal structures, with a factor of safety around 2 and 2.5. So you can find a paper published at a conference in Australia at the ISC in Brisbane of a person in the US who gathered 110 projects where they changed the foundations after they had done a first foundation based on SPT, and then thanks to the DMT they had less conservative evaluations of the modulus and switched to shallow foundations. It's on our website. I can give you this paper. So indeed, the modulus from the DMT, letting alone the VS for the moment, is already a very good modulus for predicting settlements. Now, with the addition of VS and using strong computational programs like finite element model, Plaxis, and so on, you can now put in, of course, modulus at different strain levels, and this will allow to estimate a curve that will be used in the module. So you probably referred to papers from Sara Amoroso and other co-authors that show that they, using the VS and the modulus M from DMT, so VS from the low strain and the modulus M from the intermediate strain, get an estimation of the curve, and that can be done virtually at each depth where you do seismic and DMT. so even with a high resolution with depth. And you know well that with the CPT or SPT, you're measuring at the end of the curve for very large deformations. And it's very difficult then to find a factor to say, well, but what is at intermediate strain from there? They even try to predict VS, but it doesn't always work because the soil is very different and nonlinear. So indeed, it's important in this respect to, if you want to define the curve G gamma, to get the right tool to measure maybe VS at very low strain, modulus at very low strain, the M from the DMT or from the pressure meter for the intermediate strain, and then of course if you want to measure the high strain, you can use SPT or CPT.
Very, very good. The DMT has been widely used in research and academic studies over the years. How does Studio Marchetti engage with the academic community? Are there partnerships or initiatives to encourage the research using DMT?
Oh yes, we do a lot of research testing with many universities in the world, including Brazil. I did several works with Professor Schneider from Brazil and with Professor Danziger, but there are many other professors with which I correspond. And this is just in Brazil, but we work with NGI from Norway. We did tests in their research test sites. I'm sure you're aware they bought test site of sand, of silt and clay, quick clay. And we went there with the Medusa to do so many tests. Now this data is public, and so there it's published on web, and many researchers access that data and can do research on their own. We are cooperating also with Australia, where now they are doing a lot of tests in tailings dams and with partial drainage. And so I correspond with them to give them advice on how to do the test, especially with Medusa. And we're every time getting new things, because with this new device, we are implementing new procedures, and they are also proposing things like the end of the dissipation curve is the horizontal stress, because you are measuring the horizontal stress with time after the water dissipated. And that's something I had never thought about. And mostly we are cooperating with the University of L'Aquila, where my father used to teach. I'm still in contact with Professor Paola Monaco, who wrote many papers on the DMT and worked with my father for over 2 decades. And also with Sara Moroso, who is in the University of Chieti and Pescara. And we do a lot of projects with her on liquefaction and also their partial drainage. So indeed, we are well far away from just a company doing equipment. We like to do research, to do new things, to try to find new correlations and to improve site characterization with the DMT and seismic equipment.
And that's how it started with research, and that's how you were taking your company. That's very good to
yeah. We try to do both. To give the equipment to who wants to use the DMT as it is for production, and that's perfectly fine. But we also like to push it a bit further. Okay, so that's what we're doing. And now we're working a lot on the offshore. It's 6 months since September to this Sunday that we were working with an offshore machine in a project in Genoa, west of Italy, for a project of a breakwater, 6.2 kilometers. We did over 40 CPT and DMT tests with this machine, and provided the processing also of the results with dissipation tests, 50 meters of water and up to 30 meters below the seafloor. And I was invited to present this in June in Venice, where there is the next national conference for Italy. And I will talk about this project for 20 minutes.
That's very nice. The next topic would be the Medusa, but I think there's something, I think you already explained pretty much the difference.
Well, if you want, I can summarize a little bit the main difference. The main difference is that the tool is fully automated. So you don't need a gas tank, a control unit, and a pneumatic cable. So it can work also without a cable. Some clients wanted the Medusa without a cable. So it just works without a cable, and then you retrieve it and download the data. It is more accurate. We said this because for two reasons. One reason is that it uses oil, which is uncompressible. So you have a complete control of the membrane inflation, and not that you have to flow gas and you don't know how much. If it's a hard soil, you have to flow a lot of gas. If it's a soft soil, a less amount of gas. And so that makes uncertainty in the results and in the speed with which you inflate the membrane. Now it is perfectly timed. We know exactly when the first reading occurs. You can actually program in what time to get the A reading and the B reading. And so this makes a huge difference in the repeatability. And also in terms of practical use, we decided to use the same electric cable of the CPT, so that today, like we did in this offshore test, you simply disconnect the CPT, put the Medusa, and do the test. You don't even have to change the cable in the rods or in the setup, and this makes it very rapidly interchangeable with the CPT, and even the production is important in projects because it costs much less than having to change the full setup from one test to the other. I think this is important too.
Well, Diego, this conversation was really a pleasure for me, and the opportunity to be here talking to you and see all the history that you have, that your father. He is absolutely a legend in the geotechnical world, and I'm pretty sure that he's very proud of what you are doing, pushing the company on. And I want to share with you that when I was a master's student back in 2013, he went to Brazil, invited by Professor Fernando Schneid, and I had a class with him. 12 years ago now, and we have a picture of him. It was a very nice afternoon with his class, and I was able to talk to him.
Where was that, in Rio Grande do Sul?
Yes.
Porto Alegre.
Porto Alegre. That was a very, very nice time. We had opportunity to hear from him everything that he was working on and he was working with. And it's a pleasure.
I'm happy to continue this work. I think we did a good job to expand the company and everything, but what I really admire of him is to conceive a different tool, the shape. I mean, now it's easy, you say a blade, but the fact of introducing a blade with a membrane, I think it's something that is his most important legacy for us and for the geotechnical world in now and in the future. So I'm happy to contribute to doing improvements, but they are improvements. The fact of inventing is something that I admire a lot. So.
Well, thank you very much for sharing everything with us, and I hope we can continue exchanging ideas and maybe research. And thank you very much.
Thank you for coming, and it's a pleasure to have you here. And I look forward to going on in Italy or in Brazil.
Yeah.